This for remembering some basic information about domain and range of log functions. So for logs, remember for the domain that the interior has to be positive, greater than 0. By interior, I mean what's in the parentheses, the value we're taking the log of. So there may be parentheses, there may not be. In this case, the x plus 8 is the value we are taking to the log of. That is what we want to be positive. So our domain is going to be x plus 8 is greater than 0. And if I solve that inequality, I get x has to be greater than negative 8. And since we love interval notation so much, negative 8 is the absolute smallest it can be, and it will go all the way to infinity. There's my domain. Now notice that there's no bracket. It's not or equal to, and that is because we can't take the log of 0. Why not? Well, imagine if this were log 2 of 0. This is really saying in exponential form 2 to what power equals 0. We can't do it. Nothing will give us an answer equal to 0. So it's just greater than, it's not greater than or equal to. All right, for range. Nice thing about range, if you can remember it, range of logs is always going to be, oops, sorry guys, all real numbers. You can remember that. If you're not sure, then wait till you have your graph. You can always figure out range better from a graph if you're not sure what it should be automatically. Okay, so we got that figured out. Vertical and horizontal asymptotes. Another good thing to remember, logs only have vertical asymptotes. So remember, logs have vertical asymptotes. Exponential functions have horizontal asymptotes. The vertical asymptote from a log comes when we set the interior equal to 0. So greater than 0 for the domain. For the vertical asymptote, we set that interior equal to 0. And there is my vertical asymptote. No horizontal asymptotes for exponential functions. All right, next up, moving right along, x and y intercepts. Okay, x-intercepts. Just like we would in any type of function, we set y equal to 0, we find x. So that's going to give me 0 is equal to log base 2 of x plus 8 minus 1. I'm going to start by adding 1 to both sides. And now it looks like we might be stuck, but you know we're not. Why not? Well, when logs get tricky, see if you can convert them to exponential functions. And in fact, if I rewrite this in my little Ferris wheel way as 2 to the power of 1 is equal to x plus 8, now I have x out of the interior of the log and a pretty simple algebra problem to solve, because this is really 2 is equal to x plus 8, and I can solve that for x, no problem, right? So 2 to the first, that's how I got that 2. And now to get x by itself, I'm going to subtract 8 from both sides. I get negative 6. So my x-intercept is at the point negative 6, 0. For the y-intercept, we always set x equal to 0. So I'm going to say y is equal to log 2 of 0 plus 8 minus 1, which is really log 2 of 8 minus 1. And then here's the fun thing. Log 2 of 8. Remember, any log can be rewritten as an exponential function. So this guy is really asking 2 to what power is equal to 8? Well, 2 to the first is 2. 2 squared is 4. Oh, 3. 3 is the answer. for log base 2 of 8. I still have that minus 1. I don't want to lose that. So my answer is really 3 minus 1, or 2. So my y-intercept is at the point 0, 2. And with this guy, with that guy, and that vertical asymptote, we have all we need to graph it. So let's take a look. What I'm going to do, let's go down a little bit so you can see. I'm going to start by drawing that vertical asymptote at -8. I am going to plot that x-intercept at -6 and the y-intercept at 0, 2. So if I connect these guys, oops, when in doubt, just make that point a little bit bigger. I'm going to connect those guys. I get the top shape of the graph, and then remember, graphs love to hug asymptotes. So this guy's just going to go down, 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 following that vertical asymptote. And there's my graph of f of x.